This example is like problem 8 in the exam 3 review. We have a public health researcher that wants to construct a 99% confidence interval for the proportion of individuals in the U.S. who contract a certain viral infection in a certain time. So results from a recent CDC data suggest the proportion is 0.24. Using this estimate, what sample size would be needed so that the confidence interval will have a margin of error of 0.08? So, we're using a 99% confidence interval, so our alpha is going to be 0.01. Alpha over 2 then will be 0.005. It's 0.01 divided by 2. And then your z, 0.005, you put in your left area into inverse norm. So it's going to be 1 minus 0.005, which is 0.995. So go ahead and compute inverse norm of 0.995. And that is 2.576. P hat that they give us, data suggests the proportion's 0.24. So they're telling us P hat 0.24. Margin of error we're given 0.08. And then they say what sample size. So we're using the sample size formula. That's this one. So our P hat there is 0.24. And then 1 minus P hat. So 1 minus 0.24 times our critical value, which is the 2.576, divide by our margin of error, m, that's the 0.08, and that piece gets squared. So let's compute that on the calculator. So 0.24 times 1 minus 0.24, and then we've got our 2.576 divided by 0.08, close up parentheses and square it. So 189.11. And you always round up. So this will round up to 190. Always round sample sizes up. Otherwise, you're going to get the answer wrong if you round that down. Estimate the sample size if no estimate of P is available. So if no estimate is available, you take P to be equal, you take your P hat to be equal to 0.5. And then this will be 0.5 times 0.5, which is the 0.25 that's out in front. So 0.25 z alpha over 2 over m squared. So 0.25 times r 2.576 over 0.08 and squared. So let's compute that. So 0.25 parentheses 2.576 divided by 0.08, close it up and square it and enter. 259.2. And you always round up. So this will be 260. So notice larger sample size. This is a more conservative estimate. They're saying, hey, take a larger sample size because we don't know for sure. Again, always round up on sample size. Researcher wanted to estimate the proportion in California rather than the entire United States. Would the necessary sample size be larger, smaller, or about the same? And explain what's going on there. And the point they're trying to get at here is that the necessary sample size would be the same since it does not depend on the size of the population. So if our population was California instead of the whole United States, doesn't matter. Two sample sizes would still be the same, 190 and 260.